Hess's law explains a way that we can add separate pieces together to get an end result, or a sum. As you see, the definition says, it states the enthalpy of reaction, or delta H reaction, for a process that is the sum of two or more reactions. In other words, we can add two or more reactions together to get the reaction of interest, is equal to the sum of the individual delta H reaction of each of the individual reactions, so we add it together. Here's an example in real life. Let's say you go to one of your friends and your friend owes you $5. Okay, you get $5. You go to another friend and that friend gives you $2. What is the total amount of money you got at the end of the day? $7. We added together the two individual pieces, one friend and the other friend, and get the total that you got. Another way you could think of it is that same friend, the first friend gives you $5, but you owe $3 to someone. Okay, you get $5, you give away $3, then you get that other $2. We now add them all together, and we get $4. That's an example of Hess's law. In this question, we're trying to find the heat of reaction of nitrogen plus 2 oxygen produces 2 nitrogen dioxide. In order to do that, we can't directly measure it. This reaction actually takes place in two distinct steps, which we know the delta H for. One of the steps is this reaction, and one of the steps is this reaction. Somehow, we need to combine those two reactions that we know the delta H for to sum up to equal this one. When added together, we need to come up with our end result. So what I'm going to do is I'm going to look and see, I see in my desired reaction, I need N2 as a reactant. I look at my reactions here. Oh, here's an N2. So I can go ahead and I can write this exactly as it is. Now I notice when I write this, I need one N2 in the net reaction. Here I have one N2, so I don't need to double it, I don't need to have it, I don't need to change the coefficients at all. My second reactant is an O2. I see O2 here, I see O2 here. That's not going to help me. I need nitrogen dioxide, NO2, as a product. I see here, nitrogen dioxide is a product. So I can go ahead and write this one, and I see I don't need to reverse it or anything because NO2 is a product in both of them. Now I can put these two equations together. To do that, I simply take the reactants for both and combine them on the reactant side. I have an N2, I have an O2, I have 2 NO, and I have O2. I put them all on the reactant side. I do the same thing with the products. And I have 2 NO from here, and I have 2 NO2 from here. I wrote this wrong before. It should be 2 NO. Now in my net reaction, I see that some things exist on both the reactant and the product side. Let's see. I have 2 NO over here, and I also have 2 NO over here. They're going to cancel each other out. I also see I have 2 O2s here, so I can combine them into 2 O2. I now look and see N2 plus 2 O2 produces 2 NO2. When they add together and they equal my net reaction, I get what I want. I now simply have to add together the delta H's of each individual reaction. Hess's law. I take 180 minus 112, and I come up with 68 kilojoules. That would be the delta H of this reaction. So I'm simply combining the two reactions to produce the reaction of interest. Here's another reaction. In this one, all I'm actually doing is changing not the molecule, but the structure of the substance, of the solid. Here I have solid carbon as graphite, and here I have solid carbon as diamond. It's going to take some energy to do that, or it's going to give off some energy to do that. I don't know which, exothermic or endothermic, but it's going to have to do this. So I need to find some reactions that will add together or have these things in them. I can actually use the combustion for each one of them. I can combust graphite to produce CO2 gas with a delta H of negative 394 kilojoules. It's exothermic. And I can also combust or burn diamond and produce CO2 gas and get a delta H of negative 396 kilojoules. Once again, I'm going to look and see how I can combine these reactions to get my product. I see here carbon as graphite is a reactant. Here's carbon as graphite, carbon graphite as a reactant. So I'm simply going to write this. I need one of them here. I have one in this partial reaction. So I'm going to go ahead and use that as written. I just copy it down. But I look and see now, here I need carbon as a diamond. I have carbon as a diamond, but it's a reactant. So I need to reverse this reaction. Going forward, it's exothermic. When I reverse it, it's simply going to be endothermic. The sign is going to change. So I can rewrite that one as a reverse reaction. So now I have the first reaction written forward. The second reaction I reversed and changed the sign of the delta H. I now put them together. When I put them together, I take the reactants, put them all on the reactant side, take all the products on the product side, and I see that I have an O2 on each side. So they cancel out. I see I have a CO2 on both sides. They cancel out. And I'm left with carbon graphite produces carbon diamond. Exactly what I started with. I've changed the sign already. I simply need to add these two together. Negative 394 kilojoules plus 396 kilojoules is 2 kilojoules. So the heat of reaction is 2 kilojoules. Once again, Hess's law, just reversing the second reaction to get my desired reaction. Now, another example here. We want 2 boron plus 3 hydrogen gas will produce B2H6 gas. These states and phases are very critical. As we saw in the last one, it takes energy or gives back energy. There's an energy change when something changes from one form to another. For example, from graphite to diamond. Here we go. We always need to make sure, because you could have the same thing like we did in the last one on both sides, and they're in slightly different states, and there's still an energy change. So I need to find some reactions that will add together to be this. So here's my net reaction, and I've been given 4 reactions. You'll always be given these reactions. You don't have to find them. You'll be given them, you're going to have to put them together. And I see the delta H's. This one takes a little more work. In this one I need 2 boron as a reactant. Here I have 2 boron as a reactant. Looking ahead, I need 3 hydrogen gas as a reactant. Oh, here's hydrogen gas as a reactant. And I need B2H6 as a product. Okay, here is my B2H6 as a product. So I need to start rearranging these equations. I can see here the first one doesn't need to change at all. I can see here I have 2B solid and I have 2B solid up here. Again, phases are very important. This second one, I have B2H6, it was a product. I need to reverse this reaction. So what I'm going to do is I'm going to reverse this reaction. I reverse this reaction and change the sign of delta H. So this reaction is no longer here. I now see I need some H2 as a reactant. Oh, here's some H2 as a reactant, but I see this one I need 3 times as many as is given in this. So I'm going to go ahead and multiply the entire thing by 3. I'm going to change this to a 3. I'm going to change this to a 3 halves. I'm going to change this to a 3. And I need to multiply my delta H by 3. So I triple the reaction. Every one reaction gives me negative 286 kilojoules. So 3 of them will give me 3 times as many. Great. So I have my H2, I have my B2, I have my B, and I have my B2H6. However, I can see here, I have some leftover stuff. I can see by looking here, I have 3 H2O gases here that I need to get rid of. In order to do that, I'm going to use this reaction. I can see I can cancel out this H2O with this H2O. In order to do that, I'm going to need to multiply this reaction by 3 as well to cancel out this 3. So I'm going to have 3 H2O liquid, 3 H2O gas, and once again, I'll triple the delta H. So now I can put all my equations together. So now I need to put all my reactions together. I'm not going to rewrite it this time, but I'm going to take a look and see if anything cancels. I can see here, I actually have 3 halves O2 here and 3 halves O2 here, which is actually 3 O2s. Oh, I have 3 O2s over here. They're going to all cancel. I can see here I have B2O3 solid here. I also have B2O3 solid down here. So they are going to cancel. I have 3 H2O liquids over here. I also have 3 H2O liquids over here. And I see I have 3 H2O gas here, but I also have 3 H2O gas here. And so what I'm left with is 2B solid plus 3 H2O. That's all I have on the reactant side, produces B2H6 gas. I can now, oh, that's what I wanted. Excellent. I can simply add up all my delta H's. Negative 1273 plus 3 times negative 286 plus 3 times 44 plus 2035. And I come up with a total delta H for this reaction. It comes out to be 36 kilojoules. To produce, this is called diborane, from 2 moles of boron and 3 moles of hydrogen gas. Once again, Hess's law allows me to do a more complicated thing. I had to multiply some of them by multiples, multiplying their delta H as well, and reversing some and changing the signs.